Triangle midsegment theorem. The midsegment of a triangle will always be parallel to one side of the triangle. It will be half the length of the parallel side, and it will connect to the midpoints. So looking at our diagram here, you'll see that our midsegment is right in the middle. Okay, so our midsegment is parallel to the other side of the triangle. It is also half the length of the parallel side, and again, the midsegment connects to the midpoints. The reason why it connects to the midpoints of each side is you see that this side is congruent to this piece, and then also this piece of the triangle is congruent to that piece. So we can know that they're equal, and the reason why these pieces are equal is due to the midsegment. The midsegment equation, to find it, is 1/2 the parallel side. So again, we're looking at our midsegment here. The value there is half of this side. So our first example, we want to solve for x. X right here represents the midsegment. So remember, to find the midsegment value, you take half of the parallel side. Well, this 18 represents the parallel side to x, so half of 18 is 9. So 9 represents our midsegment. On example 2, we are solving for y. Well, this time y is our parallel side. So again, y and 12 are parallel to each other. To find the midsegment, remember we take half of the parallel side. Well, since we already have our value of our midsegment, which is 12, we have to find the parallel side, which the parallel side will represent as y. So basically you're going to be doing the opposite, which is multiplying by 2. So multiplying by 2, our y will equal 24. Now we're taking it another step further. So we are still solving for x, and x is on the midsegment. However, our midsegment now is represented by 3x. Okay, and then our parallel side is 84. So we're still using the same formula, midsegment equals half of the parallel side. Well, our midsegment is 3x, and then our parallel side is 84. So we're just going to solve this equation. So we have 3x equal to 42, and then when we divide by 3, x equals 14. On example 4, we're going to be solving for x. So our x is on the parallel side, and then 4 is represented by our midsegment. So still using the equation for midsegment, midsegment equals half of the parallel side. Our midsegment is represented by 4, and our parallel side is represented by 5x minus 2. Now, with this being said, we have 1/2 times 5x minus 2. Well, we have to get rid of this 1/2. To get rid of a fraction, you must multiply both sides by the denominator of the fraction, which is 2, because that will allow them to cancel out. So then you have 2 times 4, which is 8. And then, of course, you're just left with 1s, but, 1 times anything is itself. So you're left with 5x minus 2. So from now, you'll solve this two-step equation. So you will add 2 to both sides. So 8 plus 2 is 10. Then you'll bring down the 5x, divide by 5, divide by 5, x equals 2. Another way you could start this problem out instead of having this fraction is, so your midsegment here is half of your parallel side. Well, you could look at it at the opposite. You could say we would double our midsegment, and now it will be equal to our parallel side. This way, by doing this, you don't have to worry about this step over here where you're having to multiply by the denominator by 2. We'll look at this in another example later on. So on example 5, we are solving for missing variables. The missing variables we are solving for are x, y, and z. So we will first look at x. X is right here. X is a midsegment because it's in between the sides of a triangle for those two sides and these two sides. It means at the midpoints of each one. It is also parallel to the bottom, which is 24. Now remember, to find midsegment, you have to take half of the parallel side. Well, our parallel side here is 24. So what is half of 24? 12. So all we had to do was just take half of 24 to give us x. Now let's look at y. Y is represented by an angle down here. Now you're probably wondering, well, we haven't worked with any angles in midsegment. However, we have worked with parallel sides before. Our parallel sides is now 12, is parallel to our 24 down here. So we should know by now that if we have parallel sides, we have alternate interior angles. So if we look at this transversal that goes right down the middle, if this is 55, then this angle is 55. And 55 and y are supplementary, which means that 55 plus x must equal 180. Well, x would have to be, or in this case y, it would be subtracting 55 from both sides, so y equals 125. So y is 125 degrees due to supplementary angles. Now we're left with z. Now z is over here. Well, now let's take a look at this triangle differently. So I'm going to use a different color. Look at this side right here. It's 11. Okay, 11 is represented by this side. Now, if you flip your triangle around, then this is also considered the midsegment because it bisects this side into equal parts, and it bisects this side to equal parts because you have 3 tick marks, and again the 1 tick mark and the 1 tick mark. So 11 is parallel to all of this. Okay, well, use the midsegment theorem. Well, if our midsegment is 11, okay, and to find your parallel side, well, you would take half of your parallel side to find your midsegment, but since we're given our midsegment, we would multiply by 2. So the whole side here is 22. But we want to find just z. Well, if these are equal parts, then it has to be 11. Because 11 plus 11 will give you the total 22. So in our last example, we are finding the missing link. We're finding LN. So LN is this bottom piece of the triangle. Well, we're still using the same equation we have been using, which is the midsegment equals 1/2 times your parallel side. Okay, well, since our midsegment here is x plus 2, then we have 1/2, and then we have our parallel side, which is x plus 10. This is the way you would set the equation up. And then from there, the first thing you would have to do is multiply by 2 on both sides. So the reason why we do that is so we can cancel out the fraction 1/2. So now on this side of the equation, we have 2 times, now you see them putting parentheses around the x plus 2 because we're going to have to use distributive property, equals x plus 10. Now, from here, we'll continue to solve for x. But I want to stop here to show you another way you could start this problem. The problem that most students are having is forgetting to multiply by 2 on both sides. So what you could do is say what I did earlier, which is on example 4, and say 2 times your mid-segment, and then it's set to equal to your parallel side, so you don't have to worry about this fraction 1/2. So when you start your problem out, it will look like this step right here. You would already say 2 times your mid-segment, which is x plus 2, equal to your parallel side, which is x plus 10. And then from there, you can solve the equation. So here we are, we're going to now solve for x. So we have 2 times x plus 2, which is our mid-segment, equal to x plus 10, which is our parallel side. So our first thing we'll have to do is use distributive property. So 2 times x is 2x. 2 times 2 is 4. So plus 4 equal to x plus 10. Now you would just solve this linear equation. So we can subtract x to both sides. So then we're left with 1x plus 4 equal to 10. Then we would subtract 4. X equals 6. Now, some students will then stop here thinking they're done, but remember at the beginning of this problem it said find what? It said find Ln. Ln, if you remember, on the other side is represented by x plus 10. Okay, well, we do know our x, which is 6. So we're going to plug 6 into the x plus 10 to solve for our Ln. Ln equals 16. So just remember to read the directions. See if you're finding x or see if you're finding Ln or another side to the triangle.